When we're looking at adding fractions, we'll look at a visual example first. So here we have a fraction with one section out of 4 filled in. So we know that that fraction is worth 1/4. Then we have 2 sections out of 4 sections filled in, representing 2/4. So if I'm asking you to combine these two sections, these two shapes, what do you think you end up with? Well, I can fill in my one red section of my 1/4 and my 2 blue sections. And if we look at that fraction that we have now formed, we have 3 sections out of 4 sections filled in, giving us 3/4. And that would be our answer. Now I want you to look at your fractions, stepping away from the visual aspect, and see if you can see a pattern with the numbers. What do you observe is happening? Looking at our next example, what fraction is the blue fraction? Well, we can see that it's 1, 2, 3, 4 out of 6 sections. And the next one is 3 out of 6 total. So when we go to add these together, in my answer, I will fill in my blue sections first. 1, 2, 3, 4 sections. Doesn't have to be perfect. And then I will fill in my red sections. 1, 2. I've run out of space, which means I need another thing to fill in. I filled in 2 red sections and I have 1 more. So we can see here that even when our answer exceeds the 1 section, our strategy is still working. Okay? Hopefully you noticed while we were working the pattern that we are looking at here. If we follow to the 2 examples that we used, a visual example, you can see that we are adding the numerators to find the new numerator, and it works in both, and this would work in any example we used pictures to prove. And the denominator remains the same, and our picture methods helped us prove that. So this is going to be the rule we're going to use. When you're adding or subtracting fractions, you have to keep the same denominator. And the denominator remains the same throughout, and we add, and if I change these to subtract, it would follow the same method. We want to keep it the same. So when we explore problems that have different denominators, we're not going to create a new method. That's silly. We have a method that works. We're going to use another skill that we already have in our tool belt of fractions to solve these problems when our denominators are different. Just remember, when we add or subtract, we use the same denominators throughout the problem. As I stated, when we look at this problem, 3/4 plus 1/3, we don't need to find some magical new approach to adding or subtracting fractions when our denominators aren't the same. We're simply going to use other skills to get 2 fractions that have the same denominator. So I'm already going to set up a new blank problem that will have my 2 new fractions where I will actually do my solving. So this is where we use our old skill of finding equal fractions. If you are struggling with this or you forget how to do this, please go back and watch that video or see me for further instruction before you continue with this. So I need to think of a number that both 4 and 3 can multiply into. If you're strong with your skills, you might already know what that number is. You can also list out your multiples of each number. And I usually do 4 or 5 at a time. So here I'm just counting by 4s and then counting by 3s, looking for a match. So we can see that 3 and 4 can both multiply into 12. So I'm going to set my new denominators. And this is where it's very important to show your work, and I've always encouraged this when you're finding equal fractions. How are you doing it? Show how you're doing it. 4 times 3 is 12, and as soon as I write that, I'm going to write times 3 on my numerator. So I have a new numerator of 9/12. And then 3 goes into 12 by doing times 4, and as soon as I write that, I write times 4 on my numerator, and I have 4/12. And my answer here is 13/12. So we actually have a value larger than 1. And I'm going to stop right there, because the purpose of this is practicing adding and subtracting fractions, not changing improper fractions to mixed numbers. Here we have a new problem, 4/5 minus 1/4. And I can see that my denominators aren't the same. So before I even attempt to add or subtract the fractions, I know that I need to use my other skill to find equal fractions before I begin. So I'm going to set up my new problem and find my fractions. So go ahead and pause the video now, attempt this on your own, and then come back to check your answers. I am now going to begin solving, so if you haven't paused it, do so. I'm going to write out a fact table or a multiple table: 5, 10, 15, 20, 25. And for 4, 8, 12, still not any matches. 16, still don't have any matches. 20. Now I can see I have a match. 20 will be my common denominator. So I fill in my denominators, and I know that 5 times 4 is 20, and I'm going to write times 4 right away so I don't forget. And 4 times 5 was 20, and I write my times 5 for the numerator right away so I don't forget. And now here I just need to remember that I am subtracting, and I don't end up adding my numerators when I solve. So I get 11 out of 20 for my answer.